Good morning, everyone. Thank you for joining us today in this workshop on Introduction to Effective and Practical Research Data Management. My name is Hina, and I am the Senior Research Data Services Officer based at University of Essex, and my colleague Gail is also here. The workshop format is, of course, it includes a presentation which will cover the key concepts and principles of research data management and gain insights into best practices and strategies for effective data handling, um, with plenty of tools and additional resources available. Um, just to let you know that I will be using Mentimeter to engage with practical exercises to reinforce concepts. And as Mentimeter will be used throughout the presentation, I would ask you can keep it open. You can also access it on your phone, and details on how to access will be shared shortly. And you can add your questions to the Padlet. I think Gail might have added the link to the Padlet into the chat. You can add your questions throughout the sessions. I will keep the Padlet open for 48 hours, and you are very welcome to add any further questions during that time. I will try to answer the questions at the end of the presentation, but if there is not enough time left, I will add my responses to the Padlet later on after the workshop. If you have very complex project queries, please don't hesitate to get in touch with us. We have provided our data sharing mailbox address on the last slide, and we can always set up a Zoom or a team meeting to discuss with you around the project and see how we can better help you to make sure that your data is managed effectively. So there is no problem at all for you to contacting us. You can contact us anytime through email, um, whatever you want to ask, and we are happy to help. So this is the code, and this is the link for the Mentimeter. Before I begin, just few questions on Mentimeter. If you can go to menti.com using this code, or you can scan this QR code from your phone. What are the first words that come to your mind when you hear research data management? Any thoughts on that? So ethics, organization, open access, metadata, preservation, secure, anonymity, data structures, reproducibility, privacy, headache. That's interesting. Um, Cleaning, DMP, files integrity, Excel. I hope you feel better after attending today's session, or we are able to help you later on. The one who feels headache, confidential data structures. Yeah, that is right. Everything. Um, a whole lot of admin, yes, keeping data files. Boring. Yeah, it is. It is for some people. Hard work, yes, it is, because most of the funders these days expect to share your research data if you are funded. It is a hard work preparing, cleaning data. Yeah, thank you very much. Lots of responses and all sorts of, yeah, very relevant, and that's right. Fair and GDPR as well. Yes, ethical and legal considerations, personal data, frameworks, usability. Yeah, that is great. I hope I will cover some of these in today's workshop. So the next question is there a specific aspect of data management that you are particularly interested in? Fair data. We will touch upon this briefly, but I have provided links for you that you can explore later on. Funder requirements, filling out the ethics forms, protecting data well, that's right. Meeting standards, best practice, cleaning, recoding, data management plans, archiving, securing data, ensuring compliance, writing DMPs, consistence, how to do it efficiently and without wasting time. Yeah, okay. I hope that we will cover some of these today. I have signposted to some links that you might find useful, and some of these are being I think we will be covering in our upcoming dedicated workshops. So I'll let you know once we are up to that point when we are having our workshops and which workshops we are having that just deals with that issue. So you might find that helpful. Yeah, collaboration, how to organize my data, protecting data, clinical data compliance. Yeah, I think your responses are quite helpful for us to include some of the content that is missing or to plan some further workshops. So thank you very much for your responses. And the final question, how confident do you feel in managing data? Somewhat, yeah. Most of us. So couple of you are extremely confident, couple of you are very confident, so that is really good. But majority is in between, somewhat confident. So that is really good. Somebody in the chat has written somewhat. That's fine. That's good. Okay, that's fine. Let's go back to our presentation then. Thank you very much for your responses. It will help us, as I say, in adding content to this workshop because we run it twice a year in spring and autumn. And if we can't, because already there is a lot of content, we can plan some more based on your responses. So that's really helpful. Thank you very much. So I'll be talking about the research data lifecycle in today's workshop, and which will be followed by FAIR and CARE principles. CARE data principles are a bit newer, and I would say that they are more focused. However, we will see that there's applicability to all the different data that we work with. And I will also talk you through to data management planning and why is data management planning important. We will look at an overview of ethical and legal considerations as well as do we need to do to ensure that data is secure, is stored properly, and is backed up as it should be backed up. We are also looking at data curation best practices. How do we document our data? And how do we anonymize our data? And finally, we are looking at data sharing strategies. How should we best enable future reuse from our data? And finally, we have the Q&A session if time permits. Otherwise, it will be administered via Padlet. The link to the Padlet was in the chat. You are welcome to add any questions throughout the session in the Padlet, and I think so that it's anonymous. I did make it anonymous, but apologies if I don't remember, but I think it is anonymous. So feel free to add your questions in the Padlet. So effective research data management helps ensure that research data is handled responsibly at every stage. And it means that the data is collected and used in line with ethical standards and legal requirements. And it is well organized, carefully checked for quality, and properly documented so that others can understand it. And good RDM also involves storing and backing up data securely, as well as managing how it is processed and analyzed. Once a project ends, data should be archived and preserved in ways that allow it to be shared responsibly and reused in the future. Altogether, these practices protect the reliability and integrity of the research, so that's important. UKRI expects researchers who get funding to share their data openly whenever possible. But if there are reasons not to share everything, such as privacy, security, any commercial reasons, then data can be kept restricted. They also expect researchers to manage their data carefully from the start of the project until to the end of the project. I hope you are aware that UKRI is one of the main funding bodies within the UK, consisting of multiple research councils. But this expectation is not only from UKRI, it is throughout the research community, from other funders, even from research participants as well. They do want the data they contribute to be used to better society. So the research data lifecycle describes the journey of data through different stages in the research process. It begins with planning, where researchers design how data will be generated and managed. Then next is collection, that involves gathering data through experiments, observations, or even secondary sources. Once collected, data is processed and analyzed to clean structure and extract meaningful insights. So to ensure long-term value, data is then preserved and shared in repositories or databases, making it accessible to the wider community. So finally, the cycle continues with reuse, where existing data supports new questions, validation, or replication of studies, and ultimately advancing knowledge in a sustainable way. So once we go to the reuse, the life cycle comes back again to the planning, collecting, processing, and analyzing, preserving, sharing, and then again reuse, and it continues. So now the FAIR data principles, they were coined back in 2016 by Scientific Data. The FAIR principles, which is findable, accessible, interoperable, and reusable, serve as guidelines for improving the management of research data, and they emphasize practices that make data easier to discover, use, and integrate across disciplines, ensuring long-term value and promoting open collaborative science. And you can find detailed information on these on the link provided on the slide, because it's beyond the scope of this workshop to go into more details. Some more information about FAIR. Our colleagues at the Dutch Data Archive has created this fantastic FAIR Aware assessment tool. The DANS FAIR Aware assessment tool is an online resource which is designed to help researchers evaluate their understanding and application of the FAIR principles. It raises awareness of best practices in data management and guides users in making their data more findable, accessible, interoperable, and reusable. And this tool is fantastic. And it doesn't necessarily matter what type of research you are doing, but it goes through the steps of how do you ensure your data is findable, it is accessible, interoperable, and reusable. So do have a look at this tool if you haven't yet. There is a link on this last bit, FAIR Aware Assessment tool. So that was really nice. How you make sure that how to be fair, how you are practicing these FAIR principles. Here, findable means your data should be easy for both people and computers to find, and this is done by describing it clearly using standard rules that your research community agrees on, and making sure computers can read those descriptions and giving your data a special ID, for example, like a DOI, similar to a barcode. So it can always be found and cited, and accessible here means that people know how they can get the data and under what conditions. This includes having a clear license or statement about who can use it and any restrictions, making sure there are tools or methods available to actually open or download the data, and ensuring that even if the data itself is not available forever, the information which is called metadata about it is always kept so others know it exists. And interoperable means that data can work well with other data and systems. Um, to do this, researchers use standard vocabularies or ontologies, which is commonly agreed terms, and standard metadata formats so that both humans and computers can easily combine and understand information from different sources. And reusable, I'm sure you all know that it means that data can be used again in the future by others. This is possible when the data has a clear license approved by the research community, includes background information about how it was created, follows quality checks to ensure it is reliable, and is stored in open file formats that will still work long into the future. I did mention CARE in the beginning. The CARE principles, which are collective benefit, authority to control, responsibility, and ethics, were developed to guide the governance of indigenous data. And it's fairly new. Unlike the FAIR principles, which focus on data management and reuse, CARE emphasizes that data should be handled in ways that protect the rights, values, and interests of indigenous people, ensuring that data use leads to respectful, ethical, and equitable outcomes, though it is in the context of governance of indigenous. I'm sorry, I can't pronounce that word. So indigenous data, but it is really important to think of care more widely, even if we are not working with this sort of communities. It's really important to have a think how to not only be fair, but be fair in care, because we do want to respect our participants, do no harm to our participants, and do as they would like us to do on their data. So you can read more on care on this link provided on the bottom of the slide. So now a couple of following slides are around data management planning. But before we go to that, there is a quick question on Mentimeter. So you can use this code, or you can scan this QR code from the camera of your mobile. Thank you, Gail. Gail has added the code into the chat. So what do you think is the most important component of a data management plan? Majority of you have thought that all are equally important. Some of you think that data security, storage, and backup is the most important one. Ethical and legal considerations and compliance, some think that this is most important. Thank you. Thank you very much for your responses. I I think the correct answer is all are equally important. You will see in the following couple of slides. There is a comment in the chat that all are important, but they also all fall under ethics. Yes, that's right. Yeah, so all are important, and that's right. But ethics and data compliance, and these are also most important ones. Thank you very much for your responses. So it is important to recognize that different organizations have different requirements for data management planning, and most provide their own templates. However, from a general perspective, a strong data management plan should always include certain key elements. First, there should be a clear description of the data, what new data will be collected, what existing data will be used if you're using an existing data, and whether there are gaps where no existing data can address the research question. And as some of you have mentioned, that ethical and legal considerations must also be addressed. It's very important. And this should accompany by the details on how compliance will be ensured. DMP should then outline how the data will be curated throughout the research lifecycle, including how it will be organized, formatted, documented, as well as how it will be stored securely, backed up, and where relevant, managed when dealing with personal versus non-personal data. And data sharing strategies are also essential. What data will be shared at the end of the project, how it will be shared, and whether it will be properly documented. Another critical component is the section on responsibilities and resources. Some researchers may view this as a tick box exercise, but in practice, it can be extremely useful. Clearly assigning tasks, for example, stating that one team member is responsible for a particular aspect of data management, another for a different aspect, it always helps mitigate risk, such as those posed by long-term absence. So it's always useful. It is also the place to consider what support can be obtained from institutions or funders, and whether costs such as data archiving should be factored into the research proposal. Uh, it is also essential to remember that a DMP should not be a static document. Too often, researchers submit a plan with their funding bid and then forget about it. In reality, research always evolves. So planned focus groups may need to be replaced with interviews, for instance, and the DMP should be updated to reflect these changes. Treating the DMP as a living document not only ensures an accurate record of what has been done, but also makes it easier to provide the necessary context when data is eventually shared. At present, ESRC requires a 500-word DMP as part of funding applications, though changes are expected within a shorter time with the introduction of the new funding service. But in the meantime, detailed guidance is also available on the ESRC website if you want to have a look at it. So why data management planning is essential? Well, I'm sure you all know that it helps you plan ahead and stay organized by making sure you have the resources you need and thinking early about how you will store and protect your data. It will help you. And sharing your data in a way that others can easily find, access, and reuse. So your work is transparent and reproducible. So it also helps us think ahead around reproducibility and, of course, meet funder expectations as well. So it is really essential. The Digital Curation Center has created this fantastic DMP online. Maybe most of you are aware about it, about this tool. It is a web-based platform to help researchers create, review, and share different DMPs that meet institutional and funder requirements. If you have never had a look at it online, I urge you to have a look at it because it's a fantastic resource. They always keep in touch with the funders and the institutions to make sure that the different templates are correct and up to date. And they do provide some fantastic guidance depending on the template as well. You can share the DMP with colleagues so that they can have a look at it and comment on it. And you can even publish your DMPs as well uh, from a transparency point of view. So it's actually really good to publish your DMPs uh, in the context of transparency. So that's a really good tool. If you haven't had a chance to look at it, I will suggest you to have a look at it. So now some ethical and legal considerations. And as I said earlier in the beginning, that we are just touching upon all the essential um, bits in this effective and practical data management workshop. I will be signposting to different links because there is a lot to cover, but we do have a dedicated workshops coming up, uh, and you can register for these. For example, we will be having a workshop on ethical and legal guidelines in data sharing on 16th October, and then there is a role of informed consent on 4th November, and then the introduction to copyright that includes publishing and copyright issues in secondary data use, and it's on 11th of November. So thank you, Gail. Gail has added a link to our events page where you can register. So we will go into more depth in those workshops. So why must we consider ethics when it comes to research? Well, it maximizes benefits and it minimizes risks. Again, I can't stress enough at the end of the day, our aim is do no harm to research participants. So it ensures that participation is voluntary and we get informed consent whenever possible. There are situations when informed consent might not be possible, and this is where discussions with ethics boards are really important to make sure that ethically we are still doing what we should be doing and we respect our participants' rights and dignity, and we ensure integrity and transparency is maintained. And we also make sure that we actually have clear responsibilities. We know who is responsible for what, and we give independence to our participants as well. So it's really important, but we will go through these into more details in our upcoming workshop. But there is a guidance on our website around ethics, which is quite in detail with many links to different resources. So many research projects, particularly in the social sciences, contain personal data. Some surveys are designed to be fully anonymous, which removes certain legal concerns. However, most research data will include personal data elements, and it is essential that the data handling complies with UK law, specifically the UK GDPR and the Data Protection Act. Uh, Researchers must ensure that all personal data is collected, stored, and used lawfully. And this involves applying principles such as data minimization, which means only collecting data what is necessary, and anonymization, where sensitive details are removed where possible. And it is also important to consider whether secondary researchers actually need access to identifying information such as names, addresses, exact ages, or whether anonymized or aggregated versions of the data will be sufficient. In many cases, multiple versions of a data set can be shared. For example, more detailed data sets may be made available under strict agreements, while aggregated data sets can be shared more openly for teaching or general use. And storage and access controls are another critical consideration. Personal data must be stored securely with appropriate restrictions on who can access it. So if data is to be transferred outside the UK or approved regions, additional agreements are required and participants must be informed about how and where their data will be stored. So these are, I think, most of the considerations that researchers need to keep in mind. And data retention and disposal must also follow institutional policies, which can vary. Some institutions require personal data to be kept for 5 years, while others require 10 years. So once the retention period has expired, the data must be disposed of responsibly. And alongside this, researchers need to think carefully about data sharing protocols as well, whether they are sharing personal data, anonymized data, open data, and under what terms. So ensuring fairness, transparency, and accountability is essential. And finally, intellectual property rights must be respected. Using responsible repositories that support data citation helps ensure that proper acknowledgement is given to data creators so that researchers and their institutions receive credit for their contributions. So these are some of the legal considerations when it comes to effective and practical data management. So just a quick question on Menti. This gives you, I think, a break from constant listening as well. So if you can use this quote or a quick question. So how do ethical and legal considerations in data management affect the integrity and impact of research? What do you think? Any thoughts on that? It doesn't improve it, protect individuals, predatory data inclusion. Increases applicability, ensures integrity, improve research integrity. Yeah, that's right. Ensures that data is used responsibly without doing harm. Correct. If you ignore legal and ethical issues, it might come back to bite you. That's right. Informed consent, avoid taking down data. Exactly. Improve it, and it ensures the maximization of integrity and impact documented correctly. That's right. Yeah, if your research involves people, you need to handle their personal data carefully. For example, anonymizing or gaining consent. This protects privacy and avoids harm. And being clear about how data was collected and managed builds trust in your research, and making data openly available whenever it is possible allows others to check your work, build on it, and avoid duplication. So if ethical issues are ignored, like sharing identifiable information without consent, it can damage participants, break trust, and harm your reputation as well. So definitely ethical and legal considerations, they do affect the integrity, and they are really important in terms of integrity, and they do have an impact on research. Yeah, safeguards participants' right. And also in terms of data protection laws, uh, they do regulate how personal data must be stored, shared, and used, and um, copyright and intellectual property rights. They let you or others reuse your content, acknowledging your work, your hard work, and so if you break these laws, your research could face legal action and withdrawal of funding. So yeah, these are some of the consequences. So that is really important, and it does protect participant privacy, promotes transparency. Yes, that is right. Thank you very much for your responses. Let's go back. So when we talk about managing research data, um, I think there are five main reasons uh, how it is important, the ethical and ethical considerations. All of you have almost, I think, mentioned all of these five reasons in the Menti question, so you are aware. So just a quick recap that protecting participants, some of you have mentioned that on the Mentimeter. So first and foremost, we need to make sure that the people who take part in our research are safe and their personal information isn't misused. And then maintaining and building trust. If participants know their data is handled properly, they are more likely to trust researchers and take part in future studies. And enabling sharing and collaboration. So good data management makes it possible to share information safely with other researchers, which helps collaboration and leads to better results. And ensuring long-term impact, which is by storing and handling data carefully, we make sure it can still be used in the future for new studies, teaching, or even policy decisions. And it also includes enabling appropriate risk management. um, Finally, I think good practice helps us spot and reduce risk, whether legal, ethical, or technical, so that research stays safe and compliant. Now is data security, storage, and backup. So all of the slides are available through the provided links. You can get the slides, these slides on our event page and the recording of this workshop on our YouTube channel. I think Gail have added the links to those earlier. We know that there is a lot of information, but the aim is to give you a broad overview so you can follow up on the elements most relevant to you, and of course, reach out to us if we can help further. At all times, research data must be protected from unauthorized access, use, change, disclosure, or destruction. In the past, before storage system improved, there were cases where data was accidentally destroyed before findings could be published. So to prevent this, data should only be accessed by the right people, used strictly for its intended purpose, and never altered without permission. It must not be shared with unauthorized individuals and should be safeguarded against both accidental and deliberate loss. Um, in short, protecting data means ensuring it remains secure, accurate, and responsibly used. So, when developing a digital backup strategy, it is important to consult your institution, as different organizations use different storage platforms, including physical servers and cloud-based systems. Some general best practices apply across all cases. Firstly, always control access to the devices you use to handle research data. Use strong paraphrases, lock your computer when unattended, and keep antivirus software, firewalls, and power surge protection in place to prevent data loss or corruption. These measures apply equally to both primary and secondary data. Access to sensitive materials should also be restricted. For instance, while a research team may need access to data set for analysis, they are unlikely to need access to original signed consent forms. So keeping such documents accessible only to those who require them. So that's important. Personal data should always be kept separate, secure, and encrypted. Encryption should be used on all devices that may store research data, desktops, laptops, phones, memory sticks, or any external drives. So many institutions provide encrypted laptops for hybrid or remote working, but you should always check with your institution to confirm. Physical security is equally important. Control access to buildings, rooms, filing cabinets that contain research records is also important. If you retain paper records such as consent form for a defined period, they must be kept in securely locked storage with access limited to authorized individuals only. And finally, data and equipment should be properly and securely disposed of when no longer needed. Making backup of files is a vital part of research data management, as it ensures that original data can be restored if files are damaged or lost. So regular backups provide protection against various risks, including accidental mistakes by users, hardware or software failures, corrupted storage media, computer viruses or hacking, and even unexpected power failures. By keeping secure copies, researchers can safeguard their work and avoid permanent data loss. And you can find further information on storing data on our website. There is a link on the bottom of the slide. So simply deleting files or reformatting a hard drive does not securely erase information, as the data can still be recovered. To permanently remove files, special software is needed that meets recognized erasure standards. Some of the examples include BC Wipe, Wipe File, Delete on Click, and Eraser for Windows, as well as Permanent Eraser for Macs. So for physical materials such as paper documents or media, certified shredders should be used to ensure secure destruction. And we have a lot of information when it comes to data storage on the website from Standard Storage. And yeah, you can get all these information on our website on disposing data. So again, just to give you a break and give myself a break, a quick question on Menti. So which of the following will not fully erase data from a hard drive? What do you think? Technical, I don't have any IT knowledge myself, but I think most of you have answered deleting files via the recycle bin trash. So I'm aware of that only. So majority of you have said that if we delete files via the recycle bin, yes, I think that's right. Because when you delete files and empty the recycle bin, the operating system just removes the pointers to the files. The actual data still remains on the disk until it is overwritten by new data. So with recovery tools, those deleted files can often be restored. So to fully erase data, you should need some methods like disk wiping tools that I have just mentioned, or physical destruction of the drive or encryption. So yeah, deleting files through the recycle bin only makes them invisible for normal use, but they are not gone permanently. So yeah, that is the right answer. Thank you. Thank you very much. Let's get back. So yeah, now it's data, correct? Sorry, data creation. But I think I have missed some slides. Sorry. Yeah, I just skip this slide. Sorry about that. So yeah, simply deleting files is not essential, is not uh, done if you put these in the recycle bin. I'm sorry, I'm having irritated throat. So yeah. So it's data creation now. Yeah, file formats strategy. Yes, that's right. Which format is best suited for data creation? So when choosing data formats, it is important to consider their purpose and long-term usability. And for data creation, I think the best format is the one that works well with the tools and workflows you are using, allowing efficient collection and recording of information. And for data analysis and planned uses, the format should be compatible with the software needed to process and interpret the data. And when thinking about long-term sustainability and sharing, open and widely supported formats are preferable as they reduce the risk of becoming obsolete. Deciding between open and proprietary formats matters too. Open formats are generally better for sharing and accessibility, uh, while proprietary ones may limit access. So it is best to avoid lossy formats as they discard information and can affect the integrity of the data. Um, so finally, it is also important to choose formats that are suitable for conversion so that data can be migrated to newer or more widely supported formats in the future without loss of quality or content. Um, On our web pages, as I mentioned earlier, we do make available a list of recommended file formats. Depending on the types of data, their mixture between proprietary and non-proprietary formats, because again, at the end of this is actually the community that is going to be using the data. So for example, when it comes to quantitative tabular data with extensive metadata, proprietary formats such as SPSS data or SAS are recommended. Researchers uh, will make use of those, but also the limited text and command files. So for each of them, for SPSS data, you can have the setup files as they are called, to be able to make the data with the metadata information available when it comes to qualitative textual data, XML, or even rich text formats. That's open on proprietary, but will do have a variety of qualitative textual data that's made available in Word format and is very easy to convert to Word from Word to rich text or just text files. And you can have more information on the recommended formats on our website following this link on the bottom of the slide. So when it comes to version control, it's inevitable that research projects will generate multiple versions of the same data set. And data may go through anonymization, quality checks, other processing steps might be included, each creating new versions. So it is important to identify the milestone versions you want to keep and give them unique identifiers so they can be easily tracked. For example, you should be able to distinguish between the raw collected data, the anonymized version, and the quality checked version. And changes should always be recorded. Depending on the software, this can be done within the file itself, for instance, using track changes in Word or file comparison tools, or in a separate document dedicated to version tracking. So keeping a record of changes is highly recommended, as this information can be included in the user guide accompanying the dataset. And it is also helpful to document the relationship between different data files and note their locations. So since files will often exist in multiple locations, avoid relying on a single storage point. Instead, make sure all backups are synchronized and designed a single secure location for storing milestone or master versions. So more detailed guidance on version control is available on our website with link provided on the slide. So a clear and consistent file naming strategy is also essential. And while it may seem time consuming, it quickly becomes second nature and saves significant time later. So file names should be meaningful but brief, and they should follow a consistent structure. Including dates is strongly recommended, with the preferred format being year, month, and day. Other formats may be used, but I think consistency is a key. Mixing styles can cause confusion here. So always um, be consistent, whatever format you use. As best practice, avoid capitalization where possible, since some systems, such as Unix, are case sensitive. So do not use spaces, dots, special characters in file names. Instead, use hyphens or underscores to separate words. Always ensure file extensions is not duplicated in the file name itself. Versioning should also be applied carefully. For example, if you have reached version 10, and that is the final version for archiving, the file name should reflect its status clearly. For example, you can say dataset underscore version final or dataset underscore archive rather than dataset version 10, which may suggest it is still a draft. So it is really important when it comes to versions. So a good file name should be clear, consistent, and easy to interpret. We recommend avoid spaces. Instead, use hyphens or underscores, as I mentioned earlier, between words. So, for example, a file name might begin with project number followed by the study name, the wave or edition of the data, and then the last edited date in a consistent format such as year, month, and date. Creating a file naming strategy does not need to be time consuming, but documenting it is essential, especially when multiple researchers are working on the same project. So without a shared strategy, it quickly becomes confusing, and it can become difficult to manage. So these are some of the examples. So just a quick Menti again. So what do you think? Which is an advisable file name example? Somebody has written that will we be having a comfort break at some points? Unfortunately, no, because it's just 90 minutes workshop. We do have to cover a lot of content. So I'm sorry. I think there should be 5 minutes break, but we won't be able to finish at 10:30 if we take that break. You can take a break and you can check the slides afterwards, or you can watch the workshop on the YouTube channel, the part that you missed. Yeah, so most of you have said the third one, which is the file name underscore CM, then version, and then date. So yeah, that is right. This is the format that we recommend, that there should be a year followed by the month and then the date. And prior to the year, prior to the date, there is a version as well, file name. So using underscores. So yeah, thank you. Somebody has mentioned that for accessibility reasons, future workshops should have a comfort break in the middle. Yep, thank you very much. We will plan accordingly. I think a comfort break for the presenter is, I think, always useful and helpful because continuously talking is quite hard. So yeah, I will plan 5 minutes break into my upcoming sessions. Thank you very much for the suggestion. I will definitely add at least 5 minutes. So that's not a problem. Thank you very much for your responses. So yeah, you're welcome. Yeah, so a simple but important aspect of working with survey data is to ensure that variables are formatted correctly, especially deciding whether they should be treated as string or numeric variables. And if data are incorrectly formatted, researchers who use the dataset later may have to reformat variable themselves before they can run analysis. So it is equally important to check that numerical values are assigned the correct measurement level. For example, a scale might be defined as ranging from 1 to 5, but occasionally errors occur. There may be values such as 6 or 7 appear in the data due to entry mistakes. So identifying and correcting these issues is essential, as it allows you to quality check the data set properly and prepare a reliable archived version. So it is important to define the variable measures as well. For example, in Stata, variables are generally grouped as categorical and continuous, while in SPSS, the classification is slightly different. Variables can be nominal, ordinal, or scale. So essentially, Stata uses a broader two-way distinction while SPSS provides three categories that further separate types of categorical data. So defining variable measure is something to bear in mind when you are creating the data to be used by others. It's really, really important. You should always check and record any changes made to your data, as this creates a clear history and version control, ensuring a reliable provenance trail. This process helps maintain the quality and trustworthiness of your data set, and quality assurance checks can include carefully reviewing the coding of observations or responses to spot mistakes or out-of-range values, as well as checking whether the data is complete. And adding variable and value labels where needed makes the data set clear and easy to use. And running statistical checks, such as calculating frequencies, means, or ranges, can also help detect errors or unusual values for qualitative data like interview transcript. This may involve correcting mistakes made during transcription to ensure accuracy. UK Data Service has developed a free open source tool that help researchers check the quality of their numeric data. It's called QA My Data. And it automatically looks for common problems like missing information, duplicate entries, unusual values, or personal details that could identify someone. The tool can be adjusted to match the specific quality standards of your project, and it produces clear summaries to show where issues may need fixing. This makes it easier to keep data sets accurate, consistent, and reliable. And you can check that tool. I have inserted a hyperlink here on this slide. It's a useful one for qualitative data. Not for qualitative data, for all I think data. Sorry. So yeah, Clarin provides a range of open source tools for qualitative and linguistic research, including the Clarin switchboard. And these tools support tasks such as tokenization, parsing, and annotation, and are freely available to all users. Another useful tool is ELAN, which allows flexible annotation and analysis of audio and video data, making it ideal for interviews, focus groups, and observational studies. And when it comes to AI-assisted tools like Microsoft Copilot or ChatGPT, researchers should take care with data security. For Copilot, it's important to use an enterprise license so that any data shared is stored securely within your institution's Microsoft SharePoint. And always check with your organization policies before using such tools on these AI platforms to avoid sharing sensitive data unintentionally. It's really important these days. So, and another quick question on the Mentimeter. So which of these practices is not part of quality assurance in research data management? What do you think? Yeah, almost everyone says skipping the review of out of range values. Yeah, that's right. I think quality assurance in research data management means making sure data is accurate, consistent, reliable, and usable, and checking for out of range values like a person's age recorded as 250 or a negative test score is an important part of cleaning and validating data. So if you skip this review, you risk keeping errors in your data set. These errors can lead to wrong conclusions, loss of credibility, or reduced reproducibility. So skipping this step undermines the whole point of quality insurance. So yeah, this is the right one. Thank you. There is a comment in the chat about a certification. So please, can you add this to the Padlet, because we won't be going through the chat after the workshop, but I will be keeping an eye on the Padlet, or you can email me as well. Thank you very much for your responses. Let's get back to the presentation. So we recommend a three-pronged approach to protecting participants, which is consent, anonymization, and access. And during the consent process, participants should be informed about how their data will be used and shared. The anonymization step involves treating the data to reduce the risk of re-identification, while also balancing data utility. Removing too much information, such as all socioeconomic details, can limit the value of the data for secondary researchers. So they always need a balance. This balance is often described as the dark art of anonymization. The third element, access, focuses on who will be allowed to use the data, under what conditions, and for how long. And this may involve setting up end user license agreements that clearly define rules around use and onward sharing. In the UK, researchers can also rely on existing legislation and frameworks, such as the Five Saves framework, which provides structured guidance to ensure secure access to personal and confidential data. Yeah, and you can find detailed information around Five Saves framework on our website. So these are some of the semi-automated tools available to support anonymization. And I'm not going into details around these tools because we will be having an upcoming workshop on anonymization. where my colleague, who is an expert in qualitative data, she will be going through all of these in detail. So if anyone is interested into anonymization and these tools, they can register for this workshop. So another question, quick question in the Mentimeter. Which of the following is a key consideration for effective data anonymization? What do you think? Most of you have said balancing data utility with the risk of re-identification. Yeah. I'm also mindful of the time as well. Yeah, so all of you are almost saying that this middle one, balancing data utility with the risk of identification, is an important key consideration. So yeah, that is right, because researchers must ensure that the information remains useful while still protecting individuals' privacy. If too much detail is removed or generalized, the dataset may lose its value for meaningful analysis, making it less impactful for research. And on the other hand, if too much detail is retained, there is a greater chance that individuals could be re-identified, especially when the data is combined with other publicly available information. So effective anonymization, therefore, requires finding the right balance, preserving enough detail for the data to be useful while reducing or masking identifying features to minimize privacy risks. So this balance is essential to maintain both the integrity of the research and the trust of the participants. So yeah, that is right. Thank you very much. Let's get back. So now is data creation, metadata, and documentation. So data alone is not very useful. To turn data into information, you need to understand the context it is in. Metadata is data about the data. It tells you things like where the data came from, when it was collected, who collected it, or what it represents. For example, a photo's metadata might include the date it was taken, the camera used, and the location. So together, data and metadata give you real information. Using data properly means making it easy to find and use, reusing it responsibly and correctly, in terms of ethical and accurate reuse, and also allowing others to check and repeat your work, which comes under reproducibility. So following rules and doing the right thing and keeping it safe and reusable for the future is important. So that is why these things are essential to document data. And then we have a dedicated workshop coming up on 17th of November, where my colleague will talk you through to the best practices for documenting social sciences research data. If any one of you is interested, you can register for that. So here at UK Data Service, we like to separate data documentation into two main types: data level documentation and study level documentation. Data level documentation provides information about individual data objects, such as variables in a data file or details about an interview transcripts, while study level documentation gives high level information about the overall data collection, including the research context and purpose. And you can find more information on our website. So some quick questions on the Menti. I hope you are not minding using too much Menti. It gives you break from listening as well, and gives break, a little bit break, for me to speak. too. So it's helpful and it's engaging as well. So when should you document your data? Yes, that's right. Throughout the life cycle. Thank you, Sonia, that you are loving the Menti. Thank you very much. Yeah, that is right. You should document your data throughout the entire research project from start to finish. I think there are a couple of more questions as well. So what do you think? Why is proper documentation essential in research data management? Yes, that's right. So all of you have said the first one, to ensure reproducibility and long-term preservation. Yes, that is the case. Uh, Proper documentation is essential because it makes data understandable, transparent, reusable, clear records of how data was collected, processed, analyzed. It all help ensure accuracy and support excuse me, support reproducibility and allow others to interpret and build on the research. So without proper documentation, valuable data can lose its meaning. So reducing its credibility and long-term value and impact as well. So yes, that's right. So which of these is an example of effective data documentation? Yeah, that's right. Majority of you have said providing detailed metadata and context for data. And one of you have said limiting metadata to file names to save time. Yeah, I think that's right. Providing detailed metadata and context for data is an example of effective data documentation because it explains who, what, when, where, why, and how of the data set. So it's important. Metadata describes important details such as how the data was collected, meaning of variables, units of measurements, and any processing or cleaning steps taken. So that is, I think, correct. Thank you very much. Let's get back. So now is data sharing strategies. There are several ways to share research data, and researchers can use domain-specific repositories such as data service providers, archives, data centers that focus on a particular field, or institutional repositories, especially at universities, provide another option for storing and managing research data. Some researchers choose self-preservation and dissemination, keeping their data on a secure hard drive and sharing it with those who request it. Commercial data sharing platforms offer private options for distribution, and data can also be shared directly alongside journal publications. So every method has disadvantages and advantages. So realistically, all data sharing methods, they do have pros and cons. Choosing the right method depends on the specific research project, but there are key considerations to keep in mind. First, what is the purpose of sharing the data and what do you hope to achieve? Um, Next, you need to consider whether the chosen method ensures that the data is fair, findable, accessible, interoperable, and usable. For example, self-preservation on a personal website may not meet FAIR principles, as access is often limited to contacting the researcher directly. And it's also important to consider the content of the data. Is it sensitive or confidential? Do you need different versions of the data for sharing? And ethical and legal implications must be assessed, especially if the repository does not review the contents, as this could result in sharing data that should not be shared under your research protocols. And long-term preservation is another factor. Will your chosen method remain accessible in 50 or 100 years? So that's important. Security measures, costs, and required resources should also be evaluated. Finally, consider the technology, infrastructure, and stakeholder support provided by the sharing method. And responsible repositories often offer user support to help secondary researcher use the data correctly, while simply uploading data to a repository without support may leave users without guidance. So all of these factors, they are really, really important. When I talk about responsible repositories, I mean data service providers that follow established standards and best practices in data management. So these providers ensure the integrity, preservation, and accessibility of data they hold, similar to how we have FAIR principles for data. So repositories have trust principles, which stand for transparency, responsibility, user focus, sustainability, and technology. And these principles were developed by the Research Data Alliance. And fair data cannot be fully achieved without repositories that adhere to these trust principles. They are closely interconnected, and you can have more information on the link provided on the bottom of the slide about these trust principles. So another important aspect is deposit license agreements. When sharing data with a responsible repository, it's essential to understand the agreement in place. What are your responsibilities when depositing your data? What responsibilities does the repository have? Will they share the data ethically and legally? And will they make any enhancements to improve the data? So these agreements also clarify issues such as intellectual property rights, permissions, long-term stewardship, and ensuring these points are clear helps maintain the reliability, ethical use, and proper management of your shared data. So these are really important. It is very important to check the license when using secondary data. There have been cases where researchers wanted to share secondary data with others, but the original data license clearly state that the data could not or could only be shared with the permission of the original depositors. So while we can help negotiate data sharing permissions, you can always share your code, and guidance for sharing code and syntax files includes keeping files clean, well formatted, avoiding unnecessary personal information such as researchers' names, and including comments that explain how and why the code was derived. You should also include a full citation for the data used, including persistent identifier like a DOI, along with in-depth metadata describing the files and methods. And you can also provide a README or methods document that explain why the data was derived, the original purpose, and the steps taken. This all ensures that both the code and the associated metadata are clear, discoverable, and useful to others. So if you are unsure where to share your data, you can always get in touch with us. We are here to help. For all the content I have gone through, any step that is confusing, any problem you have, you want to discuss, just get in touch. Also check our r3data.org, a comprehensive registry of research data repositories that has been active for over a decade. It provides a curated index of more than 3,000 worldwide repositories covering all academic disciplines. So there is a link on the bottom of the slide. So that's interesting as well to know. So it's the last bit before the workshop finishes at 11:30. I think there are just a couple of questions on Mentimeter, if you would like to answer. So what do you think, which of the following is an example of a responsible data sharing approach? Yeah, majority of you have mentioned depositing data in a domain-specific repository with appropriate access level. That's right. Because this is an example of a responsible data sharing approach, as it ensures that data is shared in a way that is both useful and ethical. And domain-specific repositories, they are tailored to particular research fields and provide standardized formats and metadata that make it easier for other researchers to find, understand, and reuse the data. So this in turn enhances interoperability and preserves the scientific value of the data set. And at the same time, implementing appropriate access controls allow sensitive data to be protected and ensuring privacy, confidentiality issues, and making sure that ethical standards are maintained. So yes, that is the right answer. So I think this is the last one. How confident do you feel? I hope that it is helpful. I know that it is a lot of content. It's hard to take in just one workshop, but someone is slightly confident. Well, I hope that based on your evaluation and your suggestions, I will be able to improve it for our autumn session. So thank you very much. If it is useful for you. Thank you. Yeah, I think that is the last one. Let's get back. Yeah, so here is a list of some tools and templates and tutorials which you can find useful. All the links are there. And this is our email address. And you are always welcome if you have any query, any issue. I'm always happy to have a Zoom call, team meeting, whatever you prefer if you want to discuss anything. And PowerPoint slides will be available on our website in due course, and you can catch up on the recording on our YouTube channel. Thank you ever so much. This is the email address. Yes, I have added some case studies as well for you where some of the data has been negotiated to make it available at a later date. So these are interesting case studies. You can have a look at these ones. And there are more success stories as well. So you will find it useful.